This is Chapter 8, example problem number 1. So this problem asks us to design a circuit that essentially increases the input value, which is an 8-bit value, increases it by 7. Additionally, the circuit has an output of the value, which is the sum. It has an extra output, which is valid, indicates when that sum is correct or not. Well, we'll go ahead and draw this first. So always first step, 8-bit input. The output has a valid output. Valid bit, it's a single bit, indicates when the sum output, which is also 8 bits, is valid. Now the issue here is when for an 8-bit number, if I'm adding 7 to it, it's okay most of the time, except when I get near the edges of that number. So if I, for example, the maximum value for an 8-bit number is 255, so if I add 7 plus 250, that's obviously greater than 255, and that's when I want to indicate that the number is not valid. Let's do this thing. The first thing to note in this problem is I'm always adding 7. I only know one way to add, and that's with a ripple carry adder. So I essentially want to start this problem by plopping down a ripple carry adder, since it's, once again, it's the only way I know how to add. This ripple carry adder is going to have 2 inputs and 2 outputs, as we know. We're going to ignore the carry input on this one. We don't need it, so we'll just eject it. But the output of this thing is going to be an 8-bit sum value, and the carry out here we're going to be interested in, and we've got to do special things to it. The inputs to this circuit are going to be A. We can feed that into either input. We'll just feed it into A input, and the other input is going to be an 8-bit 7. So a couple ways to do that. We can list it as 0x07, which is hexadecimal, or we could just put it in the whole binary version, which is 0000011. Both of these numbers are equivalent. You could do it either way, whatever makes your diagram clear. The issue here is when this carryout is going to be set when 7 exceeds 255, which is the maximum value for an 8-bit number. And so if it's not exceeding 255, it's going to be valid. So what I have here, when this carryout from this thing is 0, that indicates essentially that this sum value is valid. What I want to do here is essentially invert that carryout, and that right there is going to be my valid. Okay, so once again, when there is a carryout, this sum, this 8 bits here, is not a valid number. It doesn't reflect the input plus 7. I'm going to indicate that with the fact that when there is a carryout, it gets inverted, becomes a 0. So see, the carryout of 1, we'll say, gets inverted to a 0. Suddenly valid is a 0. It's understood that the sum is no longer valid. Now, a couple of different ways to do that. This is the main way, easy way. Let's do it this way. So this really, truly represents our first modular design, because what we did here was plop down a module, which is ripple carry adder module. So this ripple carry adder has no control inputs. So this circuit here, there's no other control inputs on this. We are going to call this as no control for our last bullet up there.